Hello, and welcome to Ignite 2022 and this session on new innovations in Azure Compute. My name is Mo Farhat, and I'm a product manager working on Arm-based VMs in Azure. I'm here with my colleague Stephanie.
Hi, I'm Stephanie Lemon, and I'll be talking about Azure Virtual Machine announcements.
And Varun.
Hi, my name is Varun, and today I'm going to cover how do you manage your infrastructure at scale.
And we'll introduce you to a slate of new Azure VMs, VM management, and deployment features today. We'll cover an overview of Azure virtual machine types and our recent announcements. And I'll introduce you to Azure's new Arm-based VMs and discuss their features and availability. And then I'll pass the baton to Stephanie to introduce the new L-Series V3 storage-optimized VMs and the new EBS V5 VMs. Varun will take it from there and overview VM scale sets, the new community gallery, and spot mix capabilities, including an exciting demo. And we'll close with resources to learn more. Let's dive into the overview. Azure offers a wide range of virtual machine types designed for the applications you create and the workloads that power your business. A-series machines help you get started with development and test environments at an affordable price. B-series burstable VMs give you performance when you need it and lower your costs when you don't. And you can find in the D, E, and F series a family of general-purpose, memory-optimized, compute-intensive, and confidential computing VMs that fit the needs of most enterprise workloads, while the L series is optimized for storage-heavy workloads. And of course, the N series provides GPU acceleration for AI and visualization workloads, while the H series can tackle the most demanding high-performance computing applications. We aim to provide customers choice of processors and GPUs across Azure's VM families, now including a new choice of Ampere Ultra Arm-based VMs. So let's dive into those Arm-based VMs and recent releases in the E and L VM families. First, we're proud to introduce Azure's new Arm-based virtual machine types that deliver outstanding price performance at a great price. We recently announced the general availability of the DPLS series that offers 2 GB of RAM per vCPU, the DPS series with 4 GB per vCPU, and the EPS series with 8 GB per vCPU. You can select sizes of up to 64 vCPUs, 208 gigs of RAM, and 40 gigabits per second of networking bandwidth. And all Arm-based VM types give you high-performance, local SSD options and support the range of remote storage options, including standard, premium, and UltraDisk SSDs. Customers tell us that they're using Arm VMs in a growing number of workloads, and there's broader support for Arm in the ecosystem now than there's ever been. Many workloads built on Java, .NET, Python, PHP, and interpreted languages run on Arm with minimal porting effort. And users of open-source databases, such as Postgres or MySQL, in-memory caches, such as Redis or Memcached, can also deploy on Arm with little to no changes in their application code. Now, scale-out workloads, distributed or multi-threaded applications, will also benefit from the consistent and linear performance scaling of these Azure Arm-based VMs. And we're also excited to help Windows PC developers build more efficiently with Windows 11 Pro and Enterprise Insider Preview builds running on Arm VMs in Azure today. Now let's take a deeper look at the processor behind Azure's Arm-based VMs, the Ampere Ultra processor, designed by Ampere Computing. The Ultra processor delivers high performance per vCPU with predictable performance characteristics that scale linearly with your workloads. Ultra is a 64-bit server processor based on the Arm Neoverse N1 architecture, with single-threaded CPU cores that run at a frequency of up to 3 GHz. That's among the fastest Neoverse-based processors available. And each vCPU is an entire physical compute core with dedicated resources based on the Arm version 8.2 architecture, with support for int8 and FP16 instructions that help accelerate machine learning inference applications. Arm-based VMs are integrated into the Azure experience and accessible through the Azure portal, the Azure Resource Manager, CLI, and SDKs. The Azure Marketplace supports Arm-based images and extensions, and you can use Arm-based VMs in VM scale sets and with other VM management features that you're used to today. Arm-based VMs are also supported in Azure Monitor to help you maximize the availability and performance of your applications and services. and Azure Backup to safeguard your data and recover to earlier copies as needed. And of course, the Azure Kubernetes service provides full support for Arm-based node pools. Arm-based VMs support a range of operating systems, with Ubuntu, Red Hat, CentOS, Debian, and SUSE available on the marketplace now, with support for more distributions including Flatcar on the way. We're particularly thrilled that support for Windows 11 on Arm Insider Preview is available on Arm-native VMs in Azure today. You can access the Insider Preview images on the Azure Marketplace, and they'll work great with Arm VMs up to 8 vCPUs in size. Customers love how these Arm VMs are helping them build faster and at better costs, and we're thrilled to put them in your hands. Arm VMs are available in more than 10 regions today, with more to come. And you can always check on the latest region list on the Azure Products by Region webpage. And with that, I'll hand off to Steph for more exciting updates.
Hello, my name is Stephanie Lemon. I'm a Principal Product Manager for Azure, AMD, and Intel-based virtual machines. I will be covering announcements in our mainstream VM portfolio. In June this year, we announced the general availability of our storage-optimized VMs called LASV3 and LSV3. The LASV3 VMs are based on AMD's third-generation EPYC CPU. The LSV3 VMs are based on Intel's third-generation Xeon CPU. The new LASV3 and LSV3 VMs feature high throughput, low latency, and directly mapped local NVMe storage. The new VMs come in sizes from 8 to 80 vCPUs. There are 8 gigabytes of memory per vCPU and one 1.92 terabyte NVMe SSD device per 8 vCPUs. You can get up to 19.2 terabytes on the largest VM sizes. We also improved the network and remote storage throughput up to 290% versus LSV2. With these improvements, our customers have seen tremendous performance increases over the prior generation L series. Data processing and analytics workloads are achieving up to 2 times more performance versus LSV2. We also added support for memory-preserving updates, nested virtualization, and flexible orchestration mode for virtual machine scale sets. The LSV3 VMs are available in more than 20 regions, and the LASV3 VMs are available in more than 4 regions, with more to follow. To showcase the performance of the new LASV3 VMs, we have a report published in August by GigaOM of a log analytics field test, which is a workload created to simulate the activities found in complex machine-generated log environments. They tested workloads with a volume of 100 terabytes in both single and 50 concurrent user scenarios with widely available log analytics platforms: Microsoft Azure Data Explorer, Snowflake, and Google BigQuery. As shown on this chart, Azure Data Explorer was significantly faster, on average, across all 19 queries for 50 concurrent users and at a lower cost. We are excited about what the new L-Series VM performance will enable for our customers running data-intensive workloads. If you haven't yet explored these VMs, I highly recommend you check them out. Earlier this year, we announced the general availability of EBS v5 VMs with high IOPS and remote disk throughput in more than 13 regions. I'm excited to announce today that we have 2 new EBS v5 sizes with NVMe soon to be in public preview. We will have a 96 vCPU size and an isolated size with 112 vCPUs, both with accelerated offload, resulting in up to a 2x increase in remote storage performance than our previously announced EBS v5 sizes. These larger sizes will have up to 260,000 IOPS and 8,000 megabytes per second of remote storage throughput. We will offer these sizes with or without local SSD. Stay tuned for the announcement when we are taking signups for public preview. You'll find the sign-up link on our Azure Updates webpage. And now I'll hand it over to Varun to share more exciting updates.
Hi, my name is Varun Chandelier. I'm a Principal Product Lead in Azure Core. My team leads virtual machine scale sets and Spot VMs. we focus on how do we provide capabilities to you to manage your infrastructure at scale. As Mo and Steph just talked about all the innovation which is happening in the VM world, let's talk about how do you manage these VMs at scale and how do you get the best out of this infrastructure for your applications. Most of you have known about VMSS, and it has been out in the market for some time. For those who are new to VMSS or have not heard about VMSS, let's get a quick overview. VMSS provides a simple deployment model to deploy thousands of VMs and manage them across different zones. It provides integration with Linux and Windows images as well as extensions. VMSS also provides a highly resilient infrastructure which can scale out and scale in automatically using autoscale. There are two ways to manage VMSS today. The one which has been in market for some time, which is VMSS Uniform, and the other one which is VMSS Flexible Orchestration Mode, which we released last year. Today we're going to focus mostly on VMSS Flex, as we call it, for the Flexible Orchestration Mode. What are the benefits that you get by using VMSS? It provides simple deployment and governance models. It is integrated with load balancers, so you don't have to worry about how networking is going to work. You focus on your application rather than the infrastructure that it's working on. There are a variety of consumption models, including spot VMs, pay-as-you-go. You have Azure hybrid benefits that you can take advantage of. VMSS takes care of most of the operational needs that you have for infrastructure, and that helps reduce your operational cost, which is very important when you're trying to build an application. VMSS also provides high resiliency by deploying VMs across availability zones and across fault domains, and gives you high SLA. VMSS scales out seamlessly for you to meet your workload needs and demand using your metrics, and does that instantaneously. We've been working hard to add new features to VMSS Flex. I'm happy to announce that now VMSS Flex supports all Azure SKUs that are available, including ARM64 sizes. We're also making it very easy for you to manage pools of VMs of on-demand and spot in a single scale set. More on that later in the presentation. We've also added batch API support for you to quickly manage your VMs. And now you can deploy VMSS Flex on Azure dedicated hosts as well. So Azure dedicated host customers also get the benefit of VMSS Flex. Now let's dive into Azure Compute Gallery. It has been a powerful offering for you to manage your images and update these images across different regions. We're adding more to it by providing you the ability to directly share these images with users within the same or different subscriptions or tenants. We're also simplifying how you manage and distribute your applications at scale with VM apps, which is a powerful way to distribute your applications. VMSS and Azure Compute Gallery together provide a powerful way for you to manage your applications and your images. With Azure Compute Gallery, you can update your images and publish them on different regions. And VMSS will automatically pick these images and safely roll them out onto your VMs. VMSS does this in a very safe manner by looking at the health of your infrastructure and maintaining high availability for your workload. If we notice VMs are unhealthy after an update, we pause that update and we go back to a previous good known version, providing high availability for your workload. Now let's switch topics and talk about Azure Dedicated Hosts and what we have been doing there. I'm very happy to announce that we are adding new dedicated hosts for DCA, ECA, EBS, and LAS SKUs. We're also adding a lot of VM SKUs to Azure Dedicated Host. Here is the list of all the SKUs that Azure Dedicated Host supports going forward. We've been adding a lot of features to Azure Dedicated Host. Some notable ones are support for Ultra Disks. I'm also very happy to announce that you can now deploy your AKS workloads on your Azure Dedicated Hosts as well. Additionally, customers were looking for more control of their hosts, and now you can restart your hosts using host restart to troubleshoot and manage your hosts better. Let's talk about how can you optimize your cost on Azure. There are many services like VMSS, Spot that give you great capabilities to manage costs. You can also use the tools that we provide like Price Calculator or Azure Cost Management to understand the cost that you're going to be paying and that you're paying. There are many consumption models like 1 to 3 year reserved instances, Azure Hybrid Benefits, etc. that provide great pricing models for customers to use Azure. Now let's get back to how Spot and On-Demand and VMSS is going to help you save cost. This has been a feature that has been requested by a lot of customers over the past some time. Now what we are introducing is ability for you to mix Spot and On-Demand VMs within a single scale set. You can define a percentage split between the two to fulfill the capacity. You can attain availability by providing a fixed number of on-demand VMs. You can auto-scale your VMs between Spot and On-Demand using auto-scale. And it reduces the operational overhead for you to maintain Spot and On-Demand VMs as you traditionally had to do before. Now let's get into a demo. In this demo, I'll be deploying a front-end application that can scale out to meet the demand for your traffic. I will be deploying Spot VMs in addition to on-demand VMs to save cost for my infrastructure. Let's dive into it. So here, what I'll do is I'm first searching for virtual machine scale sets. Now I'll be creating a new virtual machine scale set. I'll provide some basic details. What is my resource group that I want the deployment to be in? I will name my VMSS. I'm selecting the the region where I want the deployment to be, and I'm selecting zone. Zones are a great way for you to get high resiliency. I'm also selecting flexible orchestration mode. Now I'm selecting an ARM64 based image so that my VM sizes can be deployed with the right image. I'll go to the filter, I'll select ARM64, I'll select the Linux image. I'm going to go find the ARM64 sizes that are available to me. So I look into the D series and I select the size. That's going to work for my web servers. And I'm going to provide basic details of like what key pair to use. Now I'm going to go to scaling. And here you will notice a new checkbox available to you, which is using Spot VMs. I'm providing capacity of 50 VMs because I think that's how much I need to support my workload. And now I'm going to provide a split of how many on-demand and how many Spot VMs do I need. So I'm going with the 40-60 split. And because I want high resiliency, I'm providing a base number of VMs that a scale set should always have. I'm going to create my VMs. Now, as you see, the deployment has started. Let's go inspect the resource group that we created and see how many resources are available there. Let's refresh. I can see a lot of like NIC resources available. I'm going to select the scale set. As I come to the scale set, I'll go look at the instances. And you will notice that a lot of instances are in the creating state. Let's refresh the instance count and see where we are at. And now you can see a lot of instances are in running state. Let's inspect one of the instances and see what that instance looks like. And when I look at the properties of this instance, you will notice that this instance is a Spot instance. Let's go back to our scale set and see if the instances are ready. Before that, you should also notice that the scale set has a Spot behavior, and it also has the distribution that you provided and the base count of VMs that are provided during the deployment time. Most of the instances are created at this point in time. Now, if I go to my scaling tab, I can change the number of instances just to mimic an auto scale behavior. And I'm going to drop it down to 40 because I don't have that demand anymore. What will happen in the background is that VMSS will use that 40 number and the distribution that you provided and adjust the scale for these instances to match the distribution. So you don't have to do any custom logic yourself. And as you can see, the numbers going from 50 to 40. So it's a very easy way for you to manage your scale set and a mix of spot and on-demand mix. Thank you for watching this demo. I hope you now know how you can easily manage different consumption models like spot VMs and on-demand VMs easily using VM scale sets. Here are some of the additional resources that you can use to learn about all the announcements that we made around Arm VMs and scale sets. Lastly, I would like to thank you for attending this session with us. We are very excited to see what you will build using the technologies that we just showcased. Have a great rest of the Ignite. Thank you.